This is Blockchain 101, an introduction to the technology as well as a discussion of use cases. The goal here is to learn a little bit about the technology, where it's being used, and what it looks like for the future. As I mentioned, my name is Nick Kammerman. I'm the Director of Business Development for Chateaux Software. We are a consulting company based out of Norwalk, Connecticut. I am also the Chairman of the Connecticut Blockchain Working Group, the Vice Chairman of the Connecticut E-Notary Working Group, and a board member for the MIT Enterprise Forum. My organization, Chateaux, as I mentioned, I head up the business development. We specialize in applications development, data management, cloud services, and emerging technologies, including blockchain, IoT, AI, and microservices. Something kind of interesting, and I think what makes us uniquely qualified to build blockchain platforms and to be in that space is our background and our reach in all these other areas. When you start looking at a web or a mobile application that may feature a blockchain layer, understand that the blockchain component really probably only makes up maybe 15–20% of the actual build. The rest of it, when you think about a mobile application or a web application, is the UI, UX, e-commerce, data management, analytics, all those other components that folks use and see. That's something that Chateaux has been doing for years. And so when we started to do more blockchain platforms, it was a really natural progression and an ease for us to get into that type of technology because we already had all the background in the other areas. So we were very easy, very capable of doing soup to nuts development. From the very beginning, from ideation all the way to an actual release that has the blockchain component with it or without, depending on what you're looking for. Okay, so the goal here is what is blockchain, and that's why folks are here today. So a term that I like to use that I've heard is blockchain is tracking a digital asset as it moves through the chain of custody, and in its simplest form, that's really what it is. Whether it's used for a cryptocurrency or a supply chain or some kind of financial transaction, you are essentially tracking a digital asset as it moves through the chain of custody. So that's something to keep in mind. That is the goal within blockchains, is to be able to have that traceability and that tracking. A couple of really important terms to think about: a decentralized database as opposed to a centralized database. And some of these things are really what make up at its core blockchain as a platform and as a technology. What we see here on the left is a traditional database structure. This is what many of us for a number of years have had in our office or when we working remote, which most of us are doing these days. If you're looking for customer information or when you're logging into your work computer, you're logging into a centralized database. Most of us probably have seen or been in that server room in our office, and we're all sort of logging in and gaining information from that centralized database. As you can imagine, that kind of potentially opens itself up for nefarious activities or something that might be considered out of the realm of what you're looking to do. And in a centralized database, you only need to hit on that one area to cause some trouble. When you look at the chart on the right, or the graph on the right, we see a decentralized database. Another term that is really important with blockchain is distributed ledger. So if we look at these two graphs, on the left we see its database, a centralized database, and right underneath that you have a ledger. That is where you're tracking information, or your accounts payable, accounts receivable, whatever you're looking to track on that ledger is stored on the database, right? And it's centralized and it's not distributed because it literally sits in that one area. On the right, we see a blockchain platform. So it's decentralized and the ledger is distributed. What that means is that every single node or server or entity that is attached and accessing information on the blockchain forms this decentralization and the idea of a distributed ledger. So if it's decentralized and the ledger is distributed, that means that every entity or node or server that's connected has an exact replication, an exact copy of the ledger, of the data, of the information. Now, keep in mind, we only have access or permission to view what we've been granted access and permission to view. So even though the entire ledger is on my database, on my node, because it is decentralized, I only have access to view the information that I've been granted. And that's done through smart contracts, which we'll talk about in a second. But I think this slide is really important. I actually go back to it later because this, to me, is really the core of blockchain, the concept of decentralization and distributed ledger. On the left, we see centralized and non-distributed. On the right, we see the blockchain and the decentralized and distributed ledger. I had mentioned smart contracts. So when you're building a blockchain platform, you add smart contracts, and that is the code. And essentially, they're the rules. They are the parameters for which the platform that you have constructed need to adhere to. So we see smart contracts allow the performance of credible transactions without third-party intervention. They're put in place to set the rules to which the transactions must adhere, and multiple smart contracts may be used depending on the circumstances. When you think about allowing the performance of credible transactions, smart contracts are repeatable. So when you think about areas that blockchain is used very often, things like supply chain, things like financial transactions, very often these transactions are repeatable. They're done on a daily basis or an hourly basis. And when you have smart contracts in place, you have a true if this then that rule in place. So you know that every time I accept a certain amount of goods or I accept some sort of financial transaction, that immediately is approved because the rules have been in place prior to. So you don't constantly need, you see, third-party intervention. You don't need someone on the outside to rubber stamp it or say, yes, that transaction or that trade is acceptable, because the smart contracts in place have created those rules and allowed that to happen repeatable without interference. Okay, here's an example so we can see how they work. So the smart contract, as I said, is written into code in the blockchain. An event happens, so we'll say a delivery of goods or an expiration date on a food product. And when that happens, it triggers the next component. So supply chain, if I receive my goods and I need the next link in that supply chain to happen, as soon as I receive my goods and I click the button and say, yes, they've received, that sets in motion the next process. Very often, so if you look at this third box here, assets are released to the necessary party. That asset can be a financial transaction or the exchange of goods in a supply chain on the next step, right? So these smart contracts become triggers and rules to keep these things going, these transactions going. And then at the very end, regulators and analysts can go back and study this immutable transaction record, immutable, unchangeable. So they can go back and see all of the transactions that took place on a daily, weekly, monthly, yearly, etc. And they can go back and see where those transactions took place. And assuming that they've adhered to the smart contracts and the rules in place, there won't be any red flags that come, and you'll just see that motion. So touched on a couple of really important things there: the distributed ledger, the decentralized database, and smart contracts. And I think those three terms, decentralized database, distributed ledger, and smart contracts, are really important and really make up what blockchain platforms are, and it's a good way to think about, you know, how they work and what they're for. I have a couple of examples. The first one we created is really at Sally's wish, a blockchain story. And this is going to show you a very basic kind of childlike explanation of how these blockchains work. And then I'll go into some more real life cases and where they're being used today. So here we see Sally and her family, and they are filling out their Christmas wish list. And as you can see, Sally really wants a puppy. So the family goes online and they send an email to Santa and they say Sally wants a puppy. Of course, later that night, Sally's brothers decide that's not what we want Sally to get. We want a soccer ball. Little brothers and older brothers tend to be, well, they tend to cause trouble, I guess. So they decided that Sally does not want the puppy. She wants a soccer ball. And so they send an email to Santa, as you can see, dear Santa, Sally changed her mind. She wants a soccer ball too. Sincerely, Jimmy, her brother. Okay, and that's what Santa sees. And that's what the elves see, that Sally wanted a soccer ball because that was the latest version or the latest interaction that he received. So Sally's family and Sally received the soccer ball. And as you can see, even though a change was made, even though Sally wanted the puppy, the change was made by her brother. She's a good sport, but you can see she's not very happy with receiving the soccer ball. Next year, similar situation. Sally is really looking forward to getting a puppy this year, but rather than just going about the traditional mode of sending an email to Santa, Sally and her family access the shiny new North Pole Christmas wish list blockchain. And Sally goes on to the North Pole Christmas wish list blockchain and says that she wants a puppy. I want to pause a second here to take a look at this graph. We'll keep Sally in mind for right now, but just so that we can see what's going on behind the scenes with the new North Pole Christmas wish list blockchain. Each of these squares on here represent nodes, servers. These are entities that actually have access to the new North Pole Christmas wish list. And as you can see, it's a decentralized setup, and each of these nodes has a copy of the exact same ledger, right? The ledger is distributed, so each of these nodes has that distributed ledger copy. So when a new wish is added, you can see every single node received that same copy. Now, again, keep in mind, like I said at the very beginning, every single entity here may not have permission to view every document, but they have access, but it's on their node, it's on their server, it's decentralized, okay? So when a change was made, when a new request was made for a Christmas present, every single copy got that. And in this case, we'll look at these nodes as the different members and entities within the North Pole Christmas wish list blockchain. So everyone involved, Santa, the parents, the kids, the elves, and of course the very important gingerbread, penguin, and snowman, they all have a job to do that affects the process of getting presents out to the kids. They each have a copy. Now they may, again, like I said, they may only have access to view certain things within that, but each of those is backed up on each of those nodes. So Santa, again, is looking at the wish list, but rather than just looking at basic email, right, he's looking at the blockchain. So once again, when Sally's brothers go on there and say, Sally does not want a puppy this year, she would like a telescope, a red flag happens because Sally requested a puppy. And when the brothers went on there to make the change, they only changed it in one area. And because that's not what the smart contract allows it to do, Santa received the red flag. Now, I want to go back a second because I skipped over a piece and I think it's very important. So I'm going to go back, and I do apologize for this, to this slide right here. When you have a smart contract in place, when you put these rules in place, for them to happen and for them to take place, for it to be approved, you need consensus. And what consensus is in many cases, it's just a more than half need to agree that that transaction is legitimate. You can establish it however you want. If you have 100 nodes that access a blockchain and you want consensus to be 70% or 90% or 51%, whatever it is, you've established that early on through a smart contract. That consensus says that for that transaction to happen, more than 50% need to agree. So when we move forward and we see that Jimmy and the brothers decided to change Sally's wish from a puppy to a telescope, the reason why Santa realized this was wrong is because they only changed it in one area. It wasn't an approved transaction. It caused a red flag. And therefore, you can see here, this little green document on the left is the change that Jimmy and the other brother made, but it's not reflected in all of the areas. So therefore, it's not approved. It won't happen. Santa sees that. He knows what Sally wants. And sure enough, Sally got the puppy. And all of that took place because they used a decentralized database with a distributed ledger, and they used smart contracts to create the rules around the transactions to allow Sally to get her puppy. And as you can see, she received that. I wanted to include this slide again because I think now that we've seen a life, I don't want to say real life use case, because obviously Sally and Santa are not necessarily real life, but as we see that in action, this gives us an idea, right? So initially when they made the change from the puppy to the soccer ball, they were using a centralized database on the left. Sally's brother just needed to send one email. It made the change in the database. That's what Santa saw, and that's what Sally received, the soccer ball. On the right, we see the decentralization. We know that when Jimmy made that change, it was only reflected in one. It wasn't approved by consensus. It wasn't written into the smart contract, and therefore the distributed ledger did not reflect the fact that Jimmy had made the change. It only showed the one change that Jimmy made. Red flag. Santa didn't see that, and so therefore Sally got her puppy. A couple of real life examples, which I think are really interesting. I'm going to talk a little bit about cryptocurrencies in a little bit, and I know that a lot of people view blockchain and Bitcoin as sort of one and the same, or blockchain is made for cryptocurrencies, and we're going to talk about that in a little bit. But before I get into that, I want to talk about some other use cases because I think they get kind of lost in the discussion. IBM Food Trust is one of the largest active working blockchain platforms. And it's really interesting how they created it and why they created it. It's made in conjunction with Walmart. And what happened was several years ago, 5 or 6 years ago, Walmart had a large E. coli scare with bags of lettuce. And they needed to, as these cases of E. coli were popping up, and we know about contact tracing and things like that right now, Walmart was in a bind. They needed to immediately pull all bags of lettuce from all stores, I assume globally. And it took them a couple of weeks to actually track down the origin of where this E. coli scare was coming from. And in the time span that they did that, which I said was a couple of weeks, they had to, as I mentioned, pull every product from every store for a couple of weeks. And the amount of money and time that was lost in doing that was pretty substantial. So Walmart went to IBM and said, we want a way to have our food traceability and our food supply chain accessible in real time and to be much smoother and much more defined. And so IBM created the IBM Food Trust in conjunction with Walmart. And Walmart went out to, initially, I believe it was their 7 largest food distributors. You see some of them down there on the bottom of the slide, Golden State Foods and Dole and Nestle and Unilever. And Walmart said to all of these food distribution companies, for you to sell your products in our stores, you need to ensure that your supply chain is going to be run on this new IBM Food Trust. And obviously, Walmart, being a huge company, was able to get these food distribution companies, these Doles and Unilevers and Driscolls, to do that. And as you can see, this slide is actually a little dated. It says 2019, but in that time span, over 12 million transactions from over 8,000 products, over 6 million food products on the shelves, 500,000 traces were conducted on Food Trust. This was last year. And then this last statistic, 4 out of the top 10 food retailers, it's actually much more than that. I think it's 6 or 7 now in the US are on board. A lot of Walmart's competitors said, this is really important. This is really a great thing. And so things like Albertsons or Stop and Shop, ShopRite, these other grocery store chains, as well as other food distribution companies and food manufacturers, said this is a great thing. We want to be part of that. And they were able to join IBM's Food Trust, and they pay a fee. So Stop and Shop, for instance, joined the IBM Food Trust, and they pay a fee. And now they have all of their food traceability, all of their food supply chain. When I say all, it started out with leafy greens. They've added produce, and they're going to be adding more food types, canned goods, and et cetera, in the future. But they decided to, all of these other companies, Stop and Shop, pay a fee to Walmart and IBM, and now they are able to use the IBM Food Trust. And something that's very important that I talked about earlier when you think about distributed ledgers is the accessibility. Who has permission to view these supply chain platforms? So even though Nestle, for instance, may sell their food products to Walmart and Stop and Shop and ShopRite, each of those grocery chains really only has the ability to view their information and their data. And that's really important. So Nestle can use the IBM Food Trust for their food supply chain. Stop and Shop, ShopRite, Walmart, Albertsons, Kroger's can all go on there and access and use IBM Food Trust for their supply chain, specifically with Nestle, but they won't see any of their competition's supply chains. And it's really kind of a neat setup. And to kind of tie a bow around it, what took Walmart, I believe, was, I want to say 15 or 16 days to track back that E. coli tainted lettuce to a farm in Arizona. They can now do that in a matter of seconds, literally 2 seconds, and they can track it back to the farm, and in some cases even to the row from which some sort of produce was picked. It's really quite amazing, and that can be done in a matter of seconds, so that in the future, if they see these bags of lettuce that come through with E. coli, they don't need to pull all the lettuce. They just need to find out where that lettuce came from, which farm, and maybe even specifically which area within the farm, and pull lettuce from that area, from those shelves, as opposed to pulling all the lettuce from all the shelves. It's something that in the future, and I do talk a little bit about some of the future use cases for blockchain a little bit later on. There has been a lot of talk of this being accessible to the consumers. So if you can imagine walking through the grocery store and wanting to know the origins of some food, you in the future will be able to scan it with your phone and see that this came from this farm, or this bread was made from wheat and flour from this particular farm, and track that all the way back. And to take that the next step, think about if you were to buy a pre-made sandwich in a grocery store, go in and scan it. You, in theory, can track where the ham came from, where the tomato came from, where the bread was baked, all by just using IBM Food Trust and that traceability. And blockchain allows you to do that, because that continues along that concept of tracking this digital asset. In this case, it's a shipping label, essentially, that has the produce attached to it, but you're tracking that digital asset as it moves through the chain of custody, and you can follow that produce shipment from the grower all the way into your kitchen. So IBM Food Trust is a really cool, huge blockchain platform that is being used every day. Some other interesting ones. This is something that Chateaux built. We built it with a company called True Tickets. True Tickets came to us. They had an idea that they wanted concert and event tickets to be traceable and sit on a blockchain. And so why would you do that? Well, what it does is, you can see here, it reduces fraudulent ticket sales. It helps the fight against ticket scalpers. It allows for increased revenue for artists and performers, as well as the traceability of the ticket sales. From a personal standpoint, I know that many of us have gone online. You try to get tickets to your favorite concert at Madison Square Garden, and you go online Monday morning at 10 a.m. and you refresh, and they're sold out immediately. And now you have to go to a secondary ticket sales like a StubHub or Ticket Liquidator to buy it. And you're spending upwards of 10 times the amount of the face value of the ticket. Well, what happened there was a ticket bot or a scalper was able to go in there and buy thousands of tickets in blocks, and then immediately put them out there for resale at a much higher price. So the artist, I always use Billy Joel at Madison Square Garden. He had, before we were all stuck in our houses, Billy Joel had a standing residence at Madison Square Garden. So when you go buy your ticket for Billy Joel, unfortunately, we never buy that primary ticket. We always end up getting it on the secondary market and spending a lot more. And I think most of us are just sort of resigned to that at this point. But keep in mind that Billy Joel has no idea who's actually sitting in the audience for marketing purposes. And for revenue purposes, these tickets are resold at costs where the artist, Billy Joel, for that $50 ticket that I spent $500 for, Billy Joel only got paid on that initial $50. This would prevent that. The ticket actually sits in your digital wallet. It is unique to you as an individual, and only you can go and use that ticket to go into Madison Square Garden to see the concert. There are ways to resell it back, and depending on if using smart contracts, they want to allow you to make a profit on your ticket sales, or again, using smart contracts, limit the number of tickets that any individual can buy. These are all the things that the rules that can be put in place for a product like True Tickets. And I think this is something that many of us sort of have dealt with in our personal lives. You want to go see a ball game or go to a concert, and you end up spending a substantial amount more for a scalper, or potentially even going on StubHub, buying a ticket, downloading the PDF, and walking up and finding that is a fraudulent ticket, or that PDF has been used several times. Blockchain and a platform like True Tickets would prevent that from happening. It's pretty neat. Another product that Chateaux has built, this one follows along the lines of supply chain. Company in Connecticut called Vertrax. They have a software that truck drivers who are delivering oil and natural gas, home heating oil and natural gas, when they come and deliver the home heating oil to my house, they have a handheld. It creates a receipt that says they've delivered 200 gallons. Here's the price, and then there you go. I didn't realize this until we started doing business with Vertrax, but there are a lot of issues with tracking home heating oil and natural gas from the refinery all the way until it gets to the consumer. And if you look at this whole chart down here on the bottom, the supplies, the wellhead, the oil comes out of the ground, it goes to the refinery, the transportation, the bulk to the suppliers, those tanks, and it goes through a number of different touch points. And a lot of ordering for these companies, your home heating oil company, your natural gas company, is done on a speculative basis. And what blockchain allows them to do is have a much more open, real-time visibility of where the oil is within their supply chain and how much is needed, whether they've ordered too much or too little, and they'll see all that. And obviously a lot of it has to do with the weather. So there are a lot of factors that go into their supply chain, and blockchain has allowed them to give them a much smoother readability on their supply chain. A couple of really cool and unique features or functions or facets within the Vertrax platform that we built. The first is the use of IoT devices. For those of you who don't know, IoT, the Internet of Things, it's the idea that other components, other things in our daily life are connected to the internet. So what Vertrax is looking to do is put monitors in eventually in individual homes' tanks, as well as in the trucks and in the large supplier tanks, so that they can see, for instance, I don't know the exact amount of oil that's in my tank in my garage right now, but if I had an IoT device in there, they would be able to track the amount of oil. And when it got below a certain point, that would trigger a smart contract to notify my company to come and put oil in the tank. Obviously, this saves the oil companies a substantial amount of time and money in terms of travel and knowledge. I mean, I'm sure we've all been in a situation where, you know, the oil company comes and delivers 10 gallons in your 200-gallon tank, and you didn't need that delivery right now. This would prevent that from happening. So the use of blockchain and IoT was really a cool use of two emerging technologies that at Chateaux we were able to put them into this platform and get it up and running. Another really neat facet of this, and this is something really important for C-level individuals, is that this was the first live IBM blockchain platform that resided on AWS. Vertrex was a big, is a big AWS shop. All of their current data and systems reside on AWS, and they wanted to keep that uniformity. So they said to Chateaux and our architects and our developers, they said, look, we really want the IBM blockchain platform, but we don't want it on IBM's cloud. That was their personal choice. So we were able to set up this first live IBP on ICP running on AWS. That's a mouthful, which is the IBM blockchain platform on IBM Cloud Private, and that is running specifically on AWS. And it was really, as an aside, really an honor as an organization, and really kind of neat for Chateaux to be in a situation where we were working directly with IBM and working directly with AWS to get this up and running. And it was the first IBM blockchain platform that was running on AWS. You see here the future of blockchain. I spent a lot of time thinking about where this technology can be used in the future. I did mention a little bit about how the IBM Food Trust is something that consumers in the future will be able to use for our food traceability. There are a number of other areas that I think blockchain will be very prevalent. Now, I think people need to keep in mind it's not going to solve all problems, and blockchain is really not the solution for all problems, but there are a number of different areas where it can be used. I mentioned the food traceability. Certainly you see right in the middle the little medical briefcase, electronic medical records. Because keep in mind, you know, when we talked about permission and who can view that information, if I control my electronic medical records, I can decide which doctors have permission to view my medical records, or which insurance companies have permission to view that. And granting that permission and allowing things on a blockchain are, you know, when you think about real estate transactions, it's a very similar concept. When you're applying for a mortgage, do you want every single mortgage company to have access to your personal financial data? Or do you want to decide who has access to that information? Blockchain allows that to happen. I really am under the belief that the white whale is elections. I will caution as I say this is not going to happen anytime soon. It would need some major legislation changes. But in my opinion, the idea of elections or voting being done online, which obviously is a big debate and topic right now, to me, that is what blockchain was created for. That traceability, that anonymity, that ability to grant permission for certain areas. To me, I look at blockchain as that is the future of elections and the future of voting. There are a lot of, obviously, supply chain I mentioned, and I think when you think about, you know, food traceability, obviously, as I said, Walmart and IBM are working to include other areas of in food. I know that I've heard Honeywell talk about airplane parts, anything that you need to be tracked, and you need that immutable, unchangeable record to show the origins of where these products or digital assets come from. That's an area where blockchain is really, really strong. It's not the the solution to all problems, but it's really great in those areas that I mentioned. I did talk a little bit about one thing before I move on. The future of blockchain. I think it's really important, and it does kind of tie in with my next slide, which is the blockchain versus Bitcoin. I think what a lot of people need to understand is we've heard a lot about blockchain. We've read a lot about the concept. It's in the New York Times. It's on CNN, and maybe hopefully you're getting a little bit of a better sort of rudimentary understanding of the technology today. But I think something that sort of goes along with this, the blockchain versus Bitcoin, is with all of the things that I mentioned, the food trust and the ticketing app and tracking the home heating oil, blockchain is not necessarily something that consumers will get to play with, get to touch, get to see. You may use it a lot. And I believe that it will be something that is very prevalent in a lot of the technology as we move forward, but it's not necessarily something you'd see. So when you think about True Tickets, the ticketing app, many of us have bought tickets on StubHub, have bought tickets on Ticketmaster or any of these other ticketing services, and the interface, the concept is not necessarily unique. But the delivery, the traceability, the security, everything that sits behind that front end is unique to blockchain. So I bring this up here, this blockchain versus Bitcoin. And, I think that Bitcoin, and we're going to use Bitcoin as sort of this generic catch-all for cryptocurrencies, was really the best and worst thing for blockchain. And the reason why I think it's the best thing for blockchain is, we'll start with the good news first, is Bitcoin and these growth of cryptocurrencies, 18 months, 2 years ago, really brought the term blockchain and the concept of the technology into sort of our everyday language. People assumed that blockchain was created for these cryptocurrencies. It's not. It's a fantastic use case for it. Cryptocurrencies become a digital asset, and as people buy and sell and trade them, you're tracking that digital asset through the chain of custody. And so it's a great use case for it. The problem is that Bitcoin and cryptocurrencies are the worst thing to happen to blockchain, because first off, as I mentioned, everybody now wants to play with blockchain, wants to see blockchain, wants to use blockchain. Well, like I said, that's not really the way it works. It's a back-end technology, so you're not going to be able to touch it. You'll appreciate the use and its benefits, but not necessarily touch it. And so what Bitcoin did was, I know that a lot of people have in their mind this sort of nefarious dark web concept of Bitcoin and cryptocurrencies. And I will tell for the folks online, I don't own any cryptocurrencies. I'm not a cryptocurrency guy, but I know that people felt initially that these cryptocurrencies and Bitcoin specifically were going to be used for illegal or nefarious acts. They were going to be used to, money laundering and drug dealing and things like that. And yeah, that's a concern. In defense of cryptocurrencies, you may not know who's doing each transaction, but it's certainly traceable. And there is a way to go back and track and find out where that nefarious act happened within a cryptocurrency transaction. So there is a lot of safety and traceability for these actions that people viewed as really negative, and they viewed these negative, even though they're sort of unfounded, they viewed these negative use cases for cryptocurrencies as negative views of blockchain. And that's why I've kind of saved this Bitcoin versus blockchain, this cryptocurrencies and blockchain to the end of the presentation, because I wanted to really talk a lot about what the technology does and separate it completely from the cryptocurrencies. An example I give and I talk a lot about to people about is the idea that there's a lot of websites out there, and people can go to any website they want, and some of them are darker than others, I guess is the right word, and some of them, people may not approve of websites you go to, but they're examples of how a website on the internet works. And I think that's an analogy with Bitcoin and blockchain. Bitcoin, cryptocurrencies, a fantastic use case. They do not define blockchain as a technology, just like a nefarious website doesn't define what the internet is. They're just use cases of it. I'll talk a little bit about the stuff that I do. I get people ask me a lot, what the Connecticut Blockchain Working Group is and what the e-notarization or e-notary working group is. I'll give a quick summary of those and kind of what those entail. A couple of years ago, the Commerce Committee in the state of Connecticut was looking to create a blockchain working group. The idea behind it was to put Connecticut in a position to be a desirable place to work within this technology, whether or not you are a company such as Chateaux that builds these platforms, or you're a company that uses the technology. They were trying to further the use of blockchain and allow Connecticut to be a place where if you have a startup or you're looking to do this type of work, you might say, you know what, Connecticut is a place that gives breaks or is an appealing place to do business. So we came up with 3 bills. The first was the acceptance of smart contracts as legally binding. So we talked about smart contracts earlier and what they represent and what they do. And we wanted to say that if you have a smart contract in place, and if this transaction happens, it is legally binding by law. That smart contract, that rule in place is legally binding. And we don't need to go back and do the carbon copies or wet signatures every time that same transaction takes place, as long as it adheres to the rules of the smart contracts. So that was the first bill that we presented. The second bill that we presented was to eliminate non-competes for hiring of folks that can do this type of technology. This is very similar to the model in Silicon Valley in California. They got rid of a lot of those non-competes so that folks can travel to companies in their area and take their tools and their skill sets and bring them to another company. I know the idea behind that is, well, I'm going to train these people and then they're going to leave me. That is certainly a possibility, but you could also view it as a rising tide raises all ships concept as well, whereas you'd be hiring people also that have been trained and are bringing skills from other areas, as opposed to having these people go to school at UConn or go to school at Connecticut College or Yale, get out of college, they work for a year or two in New Haven, and then if they want to make their move to another company, they have to move out of the state very often, and we end up losing these highly trained, highly skilled individuals. So that was the second rule, was the elimination of the non-competes. And the third, which leads me to the e-notarization, e-notary working group, was the acceptance of electronic notarization, electronic remote online notarization. If you can prove who you are and do it on a video conference or a webinar like we're doing now and show your ID, show a piece of mail, then a notary should be able to say, yes, Nick Kammerman has showed me his passport, he has showed me his driver's license, and I'm going to agree that the document, whether it's a passport document or a mortgage document, whatever, is he is who he says he is, and therefore he should be allowed to do this transaction. The reason why that one kind of spun off of the before I say that, the reason we did those 3 rules within the Connecticut Blockchain Working Group is it's really hard to say, hey, come to Connecticut and do blockchain. So these are 3 areas: the remote online notarization, the non-compete, and the acceptance of smart contracts that a company that is looking to participate in blockchain development may use. Not will, not definitively, but they may use it. So in the future, if we're going to need some sort of notarization for mortgage transactions, Connecticut is a good place. A follow-up, when this pandemic started and we're all homebound, the state of Connecticut, Governor Lamont, as well as many states, New York being one of them, allowed a temporarily allowance for remote online notarization. Now, that is set to expire at some point. I believe it will be re-upped to continue, because even though we're in phase 2 of opening, I still think that there's a lot of people who are not yet willing to go to a notary's office or have someone come to their house or meet someplace. So ironically, as we were pushing these things to be passed by law, like I said, it was temporarily allowed to happen, at least the electronic notarization. So right now you could contact a notary, show your information, and have a remote online notarization take place. As an aside with that, we also, in allowing that, and hopefully in further legalizing it completely, we become Connecticut, I think, the 23rd or 24th state. So it's not, it's kind of neat to be part of, and it's definitely something that I think will benefit a lot of people. It's not so incredibly groundbreaking, but it is something that companies such as Chateaux and other companies that work in this type of development might be interested in using, and those are skills or technologies or areas where they would want them to be allowed and legal to do those kind of things. That's pretty much my presentation. I appreciate the folks that got online to listen. I don't know if there are any questions that folks have. I would love to have a conversation if this is something your organization is looking into, or if nothing else, if you would just be interested in sort of chatting. As you can see or hear, this is something that I can freely discuss. I do enjoy the conversation, and I would love to have the conversation with anybody who's interested.